So my name is Chris Jermaine, and I'm a professor of computer science and the chair of the Department of Computer Science at Rice. And it's great to see a crowd out this evening, and I'd like to welcome everyone to a short tutorial and then a panel discussion on the general topic of large language models. And so the way that we're going to run this evening is that we will have basically a super fast, it's just going to hit you, 20-minute semi-technical to non-technical tutorial on large language models. And then after that, we're going to spend the last 40 minutes of the program in a discussion with our panelists up here. And I will ask about 20 minutes worth of questions to facilitate the discussion. And then we'll also open it up to audience questions for the final 20 minutes of the evening. Okay? And so before we get started here, I would like to introduce our three of the four presenters and panelists. Actually, I'll introduce the fourth person who is not here yet first, and that is Vicente Ordóñez, who, oh, look at that. That's like, he knows how to make an entrance, right? So he was just finishing up teaching. As Vicente is an associate professor of computer science at Rice. And then continuing in this direction, we have Professor Ben Hu, who is an associate professor of computer science at Rice. And then we have, continuing this way, we have Anshumali Shrivastava, who is also an associate professor of computer science at Rice. And then finally, closest to me, we have Hanjie Chen, who is an assistant professor of computer science at Rice. And all four of our panelists this evening are experts in large language models. They've devoted their life to studying these sorts of artifacts, and so I hope we're going to hear some great stuff. So with no further ado, I would like to let Anshu kick things off by starting the tutorial portion of our program.
All right, thank you very much. Okay, so I mean, the way I think about large language models, the easiest way to think about is to start thinking of what memories are, right? So we all know about web search, like Google, Yahoo, Bing, and the information, again, like CS 101, data structures, pointers, we used to store all the information in the form of tables. So for us, memory was always about tables. So we have the whole web corpus in the world, like these are web pages, and we'll store them into tables that has some sort of a reference. And we would imagine if somebody comes up with a query, Rice Computer Science will figure out the reference and go to the web page. So everything was about tables. We know this web search dominated the world. But it was not quite human-like. For example, we all are aware, if I will type a lot of query in the search bar, it will give some garbage or not work. And what we were looking for is like maybe a query like this. A man runs without chasing, fights without anger, and loves without reason. He meets kings and warriors, yet never seeks a throne of his own. A box holds the wisdom he lives by. Who is he? If you type this on Google, you'll probably get nothing. Now, we all live in the world of ChatGPT now, so we know that in the hindsight, search was always a compromise. If I have to search something, I will look for the few keywords. Like if I want to know all the professors working on LLM at Rice, I will say Rice LLM professor, something like that, and search. Not like this. So what was the option? Again, like it dominated the computer science world and the field for about 2 decades because we couldn't find anything interesting. Now, on the other hand, what other options do we have for memories? So let's think about human mind. What do we know about that? Well, we know that, you know, the retrieval is some sort of an hallucination, right? So 2 people sitting in the same room will describe the event differently, the same event. The picture shown here, there is no triangle there, by the way. There is just some pieces of partial sectors, and the mind is filling the triangle. So the retrieval is a hallucination. And cognitive scientists and psychologists knows that mind has this tendency to somehow fill the gap. In another jargon, I will say everything is a prompt to a mind. So imagine our web search, it was like query, reference, tables, web pages. And an alternate could be, mind doesn't work that way. The only other mind that we know of is a human mind, and everything is a prompt. What comes to your mind when I say Humpty? Well, Dumpty. What comes to your mind when I say Eiffel Tower? Where is it? Paris, France. It's also very contextual, as in it's not deterministic. For example, sitting here, if I say rice, you will think something like Rice University is awesome. But maybe if you're sitting in a restaurant and I say rice, you will say, well, rice bowl is delicious. And it's not just text. For example, there are these games called an emoji movie game. I'm showing you an example. I'm showing you 4 emojis, and I will ask you, what movie comes to your mind when I show you this emoji? By the way, any guesses? What? Okay. It's one of the hard ones. It's actually Inception. Dream within a dream within a dream. So there is another way to create memory, or at least we are aware of, which is everything is prompt. The query is nothing special. Query is just a prompt. And that brings us, obviously I'm grossly oversimplifying 2 decades of research in computer science, but there was this idea that if you want to understand LLMs, what they are literally doing is they are literally doing one task and one task very well, and this is prompt completion and like literal rote memory of prompt completion. So while I may imagine that the mind is about creating tables of web page, that's one way. The other way could be literally how humans learn, like keep in the rote memory. Just keep memorizing. This is Rice University in Houston, this is Rice University in Houston, and whatever is being out there, you just get that in the form of a rote memory. That's another way to memorize. And there was certain attempts on how we do this. And when we do this at scale, we landed into something like LLM. So just to go a little bit into it, the task is like, you create these tasks like, this is Rice University in. What should come to your mind? And we take large neural networks. Again, these are like probabilistic models. And putting it in other words, it literally is trying to predict this table, which is a table of probabilities as to what are potential next words. Right? So this is Rice University in Houston. It could also be this is Rice University in action. And if we can predict the next word, we can recursively predict everything. You need to peel bananas, not apples, before eating. So you need to peel bananas, then you need to peel bananas, then you predict before, then you predict eating. So you can recursively generate the whole language. In fact, you can recursively memorize a text. For example, if you just have to memorize a chapter, you can memorize it very easily with a small model like this, and it will memorize a whole chapter. But what if I have to memorize the whole web? And this is where there is no free lunch theorem, and the origin of the word large in the large language model comes in. And this is a basic theorem in information theory. And the nice thing about information theory and math is, it really doesn't matter whether you have a neural network or whatever you have. If you have a program, and you expect the program that I give a variety of prompt as an input, and it is my expectation that you will generate a variety of prompt as an output, then if the variety is too much, the description of the program cannot be small. As in, you will need a lot of memory for that program. It doesn't matter if it's a neural network, it's a table, or whatever you do behind the scenes. It's mathematical. So it was very clear to people that if I have to create a prompt, which is like maybe as simple as food or no food, then you are looking at a brain of a fly. It doesn't need a lot of memory. But if you want all sorts of intelligence, you need a brain of a human, you need a lot of memory. And what people realize is that unless you're talking in the orders of the billions, you're really not making sense. This is mathematically impossible to even memorize Wikipedia or the web of information with few hundred or thousand or even 10,000 parameters. And that is the origin of that word large in it. Now, to put it simply, LLMs are nothing but prompt completion at scale. So there is this hypothesis, again a gross oversimplification of 20 years of world research, that if you do this prompt completion at scale, you will probably get AGI, or artificial general intelligence. Now, the story goes like this. Obviously, this is not the first attempt to get prompt completion. Maybe people have done it in 50s, maybe in 70s, maybe 80s, but they were probably doing it at a scale of 100 or 1,000 parameters. It was probably as good as garbage. The same thing, prompt completion, when started becoming about at 100 million parameters, something interesting started to happen. And we got to about like BERT and some interesting language models. OpenAI then took that 117 million parameter, which was their GPT-1, what was barely noticed, went to about 1.5 billion parameters in about 2019. And then they started registering a phenomena that they have not seen before. And they were convinced that we'll take this to the next level. Obviously, GPT-2 was not as good as Google, was not as good as Microsoft at that point of time. But the same idea, when taken to about 175 billion parameters, as in at scale, large context, more data, more parameters, that one same rote memory task, next word prediction, complete the prompt, resulted in something like GPT-3. And in fact, it is aligned with what we have seen philosophically. For example, in philosophically, people always say that memory at scale is mind. There are a bunch of quotes that says that mind is maybe just a bundle of thoughts. And if you know how to manipulate it, you will get a very smart mind. And again, we are here in 22. So if you give the same query, a man runs without chasing, fights without anger, and loves without reason. He meets kings and warriors, which I mentioned. What you get an answer is an interesting outcome. It's probably Forrest Gump, who runs without chasing, literally runs without specific goal in mind, fights without anger, loves without reason, meets kings and warriors, presidents, soldiers, and famous figures. And while there is no literal box of wisdom, his quote, "Life is like a box of chocolate," might metamorphically fit. So this was an alternate form of memory at scale that is literally something that we have not seen. It was different. And when done at scale, it created ChatGPT. Now, before I hand it over to Ben, I mean, obviously we have been seeing AI for a while, and every time we believe that it's going to have a huge impact. This time it's slightly different, because AI, before LLMs, if you look at who it enables and what tasks it enables, it was different. It was about enabling data scientists, a profession that already requires a lot of effort to go there. Right? AI was for data scientists. If you want to automate object detection, you need to collect data, write a program, and then get it integrated. You need a lot of data. You need a bunch of developers. You need data scientists. You need to go through a very small funnels, and there were not that many of those. But LLMs, there are, as we speak, there are companies that are literally taking non-experts, and with this LLMs, they are now performing at par or even better compared to experts. The barrier to entry is literally nothing. It's natural language, and the kind of tasks that can be automated seems like most non-blue collar tasks are now on the verge of automation by a task force that is literally everyone, which I believe is going to be very different. I'll stop here and I'll pass it on to Ben, who will talk about the next phase on efficiency and DeepSeek.
Yeah, thanks, Anshu, for introducing where large language models and ChatGPT come from. And here I'm gonna continue the discussion. As we can see from this very fancy evolution tree of large language models, actually since 2018. By the way, this very fancy graphics has been done by our own students. Yeah, and it's been like everywhere since like last year. And since 2018, hundreds of large language models, commercial versions, open source versions have been everywhere. And among so many options, why DeepSeek got so popular recently? And actually, this is one of the main reasons why everybody gathered here, right? So who are them? And what are the magic behind the DeepSeek versions? And actually, DeepSeek, this is a very small company with less than 200 employees. And although they themselves, they are small and tiny. However, there's a big tech giant behind them. And it's very much like a D-Shaw-like hedge fund. And that's why they have access to abundance of resources, both computational and people, behind these developments and research. And for the last few years, DeepSeek has been a consistent contributor in open source communities, and they have released multiple versions, including DeepSeek R1, which has become extremely popular since 1 month ago. And there are two main reasons I would like to conclude why DeepSeek is so popular and why it stuns the world. The first reason I would like to emphasize is this is an open source model comparing to another commercial model, OpenAI O1. So we have access to all of the parameters, and we have access to many technical infrastructure behind the DeepSeek. And it offers the state-of-the-art reasoning capabilities. This is one of the main reasons. And as we can see from the left-hand side of the figure, if we compare DeepSeek R1 and the OpenAI O1 model, which is closed source, commercial version, we don't have access to the parameters, it achieved a very similar performance among these two models on two representative tasks, including American Invitational Mathematics Examination, which is a mathematics task, and another coding task based upon software engineering bench. They achieved a very similar performance, and often it is even better. And the second reason why DeepSeek became so popular is it's extremely low training cost. As we can see from the table on the right-hand side, comparing all of the specifics between DeepSeek and Llama, which is the best open source model before DeepSeek. And almost all of the numbers are similar to each other, except the cost. The cost of DeepSeek is less than $6 million, comparing to Llama 3, released by Meta, which costs over $100 million, which is insane, right? So it spends only 5% of the cost and achieved similar performances and open source to everybody to use. That's why it stuns the world. And here are the magics behind the DeepSeek releases. And today I'm gonna spend 2 hours to go over these two papers in detail with you. No, I'm kidding. So Chris will kick me out, okay? So, however, I do want to highlight some technical points from these titles and abstracts about reinforcement learning and mixture of experts, respectively. So before talking about reinforcement learning, let's take a look at what is reasoning capable LLMs, okay? So actually, instead of traditional large language models, which will somehow deal with the question, how many are in the word strawberry, as a direct prompt and feed into large language model and get the answer directly. Instead of doing this, actually, many methods have been proposed to process a question in a chain of thought. What does it mean? It actually decomposes the question into multiple steps, as shown in the example. First step, write down the word, identify each letter in the word, and count the occurrences of the letter R. And then it will get the right answer 3 times appeared in the word strawberry. And by doing this, it is recognized by the community. We will be able to deal with many tasks much easier and much more effective than before. And as we can see from the right-hand side, by comparing GPT-4o model, which is considered as a general language model released both by OpenAI, actually the O1 model, which is a reasoning-capable model, it achieved much better performance than the general large language model in these 2 representative tasks, in mathematics and coding tasks. And there are 2 popular ways of doing this. The first way is a neural-based reward model for achieving reinforcement learning performances. And here we show one example. For example, if we are giving a user query, write a RAIKU for RISE universities. And traditionally, what we are gonna do is oh, how about we generate 3 answers? And then we employ a neural-based model to identify which answer is the best. And then we will favor this best answer in training our large language models. Unfortunately, while this looks pretty decent, however, like these three answers, they themselves are pretty like subjective, very complicated. It's very difficult to annotate, even for human annotators. Instead of doing this, another way is called a rule-based reward model. What we're gonna do is like, hey, instead of this kind of complicated, very subjective tasks, how about we utilize some like very clear logical questions, like what we can see in the example. What is 37 plus 58? This is a very simple mathematical question. By decomposing this task itself into multiple steps, we will be able to very easily annotate which one is like ideal and which one is correct with an objective answer, right? So by doing this, it is believed like rule-based reward models, they can guarantee a clean and accurate feedback, and such that we will be able to train a much more effective reasoning-capable large language model than before. And the second technical point I want to make here is about a mixture of experts. And it has been a belief like the bigger the model is, the better the performance will be. As we can see from here, X represents the number of activated parameters in the scale of billions. And the Llama 2 7B model on the right side and the far right side, it achieved the best performance. And however, so an idea is like, do we really need to activate all of the parameters in the model while it's so big? Sometimes it's too big, right? Do we really need to make use of all of a human being's neuron to answer one question? And the community gives the answer, no, probably not. We can only activate like a part of these neurons, known as a mixture of expert model. And by only activating like less than 3 billion parameters, DeepSeek will be able to achieve similar performance comparing to the 7 billion model. And I would like to give you an example in the medical informatics I'm working on. So for example, a patient walks into a hospital and the patient is suffering from the ear infection problem. Do we really need to call for all of the physicians in the hospital to form a committee and give a treatment plan? Actually, we do not, right? Often what we are gonna do is like, we can only like ask a home physician to have a basic diagnosis, and then we will ask an ENT doctor, just one ENT doctor, to deal with the problem. And actually the mixture of expert architecture is doing exactly the same. And when we have this input, we do not need to activate all of the experts, in which DeepSeek has like 256 experts. We don't need all of them. We only activate part of them, and it's a very small number, 8 experts out of this more than 200. And by doing this, we will be able to deal with the training and the inference in a much more efficient way than ever before. So that's pretty much my very high level and quick introduction about DeepSeek. Next, I'm gonna hand this over to Chris, and we will have like a public QA session.
Okay. Yeah, so I guess everyone up here should make sure they're mic'd up.
All right, we're ready, right? Yes, sir.
Okay, so let's go ahead and get started. So the first question I would like to pose to the panel, so we heard this term AGI, okay? So I think Anshu mentioned it. So what is AGI? Have we reached it? Are models like DeepSeek actually AGI? And if not, how long is it gonna take?
So I think, look, so AGI is a term that was defined to more or less portray, like where AI can achieve human-like capabilities.
What does it stand for first?
So artificial general intelligence, it stands for a capability where you cannot tell apart between a human and a computer. That there was some definitions like that. But I think in today's world, like talking about AGI, they are more or less saying next level capability. Right? For example, the stress on large and language models. So language models always existed like since 2015. But then people said, no, it's large language models. It's something beyond language models. And I think same is happening. The word AI is so much popular for a while. how do you tell people, no, I'm really doing something at the next level? It's probably AGI. That's what I would imagine the OpenAIs of the like are trying to go for.
Okay, I saw Vicente frowning over there. So let's hear the rebuttal.
I mean, again, AGI is not a term that we academics use for a very long time, but now, I mean, it has been taken even into serious circles. I mean, but it generally refers to a system that is capable to perform a very large arbitrary number of tasks, right? That not a single human can perform well, essentially, right? So for me, that's artificial general intelligence. Are we there? I mean, some people claim that we are seeing some signs of being there. I mean, at least, I mean, we don't have a system that can do as well as both a lawyer and a physician and an architect, right? But we have a system now that is able to do at a rudimentary level better than the average human in all these fields, right? Not better than the expert on these fields, but better than somebody who doesn't even have a passing knowledge in that field. So in a way, like that's why people are talking about the term more seriously now. But that's, are we there? I mean, like, it depends how you define it. I mean, we're there in the sense that we now have a system that is knowledgeable in a lot of fields, but we're not there in the sense that it doesn't reach the human expert capability in majority of those fields, or I would say any, but majority at least of those fields.
Okay, thanks, Vicente. So the next question I wanted to ask is, do these models actually think in the same way that humans do? Do we have an understanding of what they're doing sort of conceptually beyond the mathematical model, right? Do we have a good picture for what's going on? Hanjie?
Yes. Yeah, I think the large language models, because of the way that they generate responses, makes them look like human thinking. But honestly, I don't think they really think like us humans. Because for human thinking, when we think about something, we probably already have the idea in our mind, and then we just need to verbalize the idea, right? But for language models, they are actually, the task they are doing, like Anshu just introduced, they are predicting the next token and then repeat this process, generating the whole responses token by token. So it's hard to tell, or it's hard to see whether the model already has the idea and then verbalizing like us human, or it just generates the text and then the idea is already there. Yeah.
Okay. Anything else to add, anyone?
I will just say that the question needs to be portrayed as what is our perception of how we think and whether we think that LLMs are doing that or not. So I will slightly, I mean, I'm like more of a believer. I think even rote memory, we have, eliminated rote memories like, well, it doesn't work. Maybe it doesn't work for us, but we really don't understand mind. So we think that our thinking may be linear. But then there are examples like Ramanujan, right? I mean, I don't know if you know about The Man Who Knew Infinity, right? The movie in which formula just appears in his mind. And those formulas were proved like 50 decades later, right? Sorry, a few decades later. So, I mean, I would say that we really don't know how we think. So, yeah.
Okay, thank you. So the next question I wanted to ask is with regard to safety of these models. So is it possible for these models to somehow escape and wreak havoc in the real world? What is the danger?
Yeah, so probably I can get it started. So I can give you a very simple example when robotics is equipped with AI. So you can imagine how in the future, so robots are very capable of doing a lot of stuff, and we can give the robots a very simple instruction. So try to make sure you are not going to run out of battery. Okay, with this very simple task, so what you are gonna think robots will do? So probably one way is like with human beings, we will think the robots, they will, once like they run low on batteries, they are going to charge themselves. But actually, sometimes they are not going to do this. They are going to find a shortcut. Hey, the human beings ask us to do a lot of tasks. How about we kill all of the human beings? we're not gonna run out of battery, right? So this is a very simple shortcut. And we did observe a lot of such shortcuts in this kind of robot learning experiences and see a lot of examples in medical informatics in many different applications. So sounds scary, right? So I think from this example we can see, I do think like safety is a very important problem and we have to treat it very seriously.
So I mean, what is the chance that one of these models that's living in a GPU server actually finds a way to get out of the GPU server and influence the real world? Is this just science fiction, or is this a real thing?
So to me, I think likely it will happen once they have the capable to access the physical world. And it's not surprising to me, at least. I know it's still a controversial conversation, but that's my personal belief.
So I would just add that it's a theoretical possibility, yes, because the moment we say something is smarter than us, they could do, like it's theoretically possible. But also what is theoretically possible is like there are also physical limits, right? Something jumping out of GPUs and killing all of us seems unlikely unless you give them arms and capabilities to kill us, like maybe Skynet. If you power that with Gen AI, we don't know. But until we do that, probably I will be comfortable.
Okay. So just to, did you want to add something, Vicente?
Yeah, maybe I'll say something, like it depends on how do you define agency in a model, right? Like, I mean, what does it mean that a system has agency, right? I think like still we are, I think if there is any danger at the present moment is like people trust these models too much. With things, but I think that's with any technology. I think when computers were given agency, I don't think anybody would say like computers were given agency in the early ages of the internet, but there were computer viruses that run amok. I mean, systems that had not any kind of safety, right? But it was people writing the software and maliciously giving these programs the ability to do things that were destructive. I think that for me at this present moment is the only way I see one of these models doing something bad. It's like somebody purposefully giving the model agency over some domain, right?
Okay. So just to follow up on that, so Vice President J.D. Vance was recently in Europe, and he chided the Europeans, and he said, and I quote, "We need international regulatory regimes that foster the creation of AI technology rather than strangle it. And we need our European friends in particular to look at this new frontier with optimism rather than trepidation." So do you agree with that? What sort of regulatory structure, I guess that's a massive question, so we'll try to keep it to 2 minutes, needs to be around?
I mean,
it's
hard to answer in a very short answer that, right? I think there are real concerns, like around. I mean, there is one extreme where you have no regulation at all, and there is the other extreme where you do have some at least basic considerations for privacy, like what is the extent to which companies can use the data they already have about you to train these models. I mean, are we granting them access by default by having our data in their systems? I think these are basic questions that should be addressed. And I think like if you don't want to even address those basic questions, I think that's not a good start of the conversation. And I cannot speak for what he means in these cases. I mean, there are a lot of things to worry these days, I feel.
So Hanjie, it looked like you want to say something.
Yeah, I agree with him. I think he points out a very good balance between the technical innovation and versus the development of AI, right? And also, I think it's critical to integrate the safety considerations when we develop AI systems. And I would say that it's even debatable whether these AI systems have self-consciousness, which I believe not. Yes, it's still debatable, but let's assume that this AI system, they do not intentionally to output anything harmful, but since they were trained on vast amounts of data, they may learn useful information and knowledge, but they may also pick up some misinformation, and so it's hard to control their outputs, at least for now, for the AI system. They are, actually, I would say they are out of our control. Yeah.
Okay.
I would like to make some like a very personal and biased comment, because like circling back to a former question by Chris, like I still think like artificial general intelligence is still in the very early stage, and I somehow threw out a very scary story, but actually we are still far away from like worrying about this kind of situation. That's why at this stage, while we do need to like start to think about these problems, probably, I mean, embracing the technology development and harnessing the power of AI still is with a higher priority. And as long as we don't give up and we don't stop thinking about the regulations and the safety problems, we should be okay in the short term, yeah.
Okay.
We human beings still have time, so.
So I want to switch gears and ask a technical question that wasn't addressed in the presentation. So I would say that the most important technical idea powering modern AI models, at least large language models, is this idea of something called attention, right? And so can someone in 2 minutes summarize what the attention computation these models are doing is, and why bigger and bigger attention is better?
So, I mean, attention is, simply put it, let me give you an example. I'm trying to say a lot of things. So let's say I talked about Paris, then I talked about physics, then I talked about math, maybe politics, and suddenly I came back to Eiffel Tower. Then I need to pay attention to what I just spoke about Paris to make sure I'm not just regurgitating the same things and making sense, right? So in prior systems, this mechanism was not there. The way it was implemented was everything that I have said so far will become a representation, if I may, and I decode what I'm going to say from everything I have said. Now, obviously, this is not scalable, because if I said 1 million words, if I want to say next, it doesn't matter what order I said all those 1 million words. Whereas if I am saying something now, I better talk about attention rather than I talk about large language models, right? Which I just spoke a few minutes back. So there was this idea that, okay, whatever I spoke, it all needs to be in the context, because I'm creating intelligent agents. They need to know the whole world of what I spoke, but what I'm trying to speak next needs to focus on everything, some parts of what I said before, so that it can relate to what I speak next. So for example, if I talked about museums of Paris and I came back after a long rant to Louvre, I will now start paying attention to what I talked about the Museum of Paris to say what is next. And I will ignore most other conversation because that are not pertinent. So this behavior, when this was mimicked in the architectures of neural network, was called transformers, was one of the primary reasons why we were able to achieve language generation like humans. And so this capability to pay attention, as in correlate what is in the context, and then figure out, you remember the next word prediction, what I just said in my second or third slide. If I have to predict what I want to say, I want to focus on what I just said and maybe everything that I said in that context. And I can maybe ignore what we talked slightly before. So this phenomena, when it was mimicked in mathematical form, result in attention.
Anyone want to add anything? Okay, so I want to bring it back to DeepSeek. So the announcement of DeepSeek was a big deal, right? And NVIDIA, the GPU maker, right, lost a huge amount of market share. But I've heard a lot of academics say that it's not real, that DeepSeek cheated. And what I specifically hear is that people will argue that DeepSeek probably distilled its weights from llama, right? And so why might someone call that cheating? Does that mean that DeepSeek didn't really spend just $6 billion? And is this claim that DeepSeek cheated simply not true? So what are your thoughts of that?
I can get it started.
Go ahead, Hanjie. Or Ben.
Oh, yeah, I can get it started. So firstly, so this is my personal guess because there is no like a formal like source of the information. My personal guess is yes, they distill the information and from multiple other models. However, this is still, I would like to emphasize, this is still kind of the gray area. And there is nothing like, there's no like formal agreement not to distill each other's information, at least to the best of my knowledge. That's first.
Can you describe, what does it mean to distill one model from another? And if they did that, why would somebody maybe say, oh, it's cheating in the sense that they didn't just spend $6 billion?
Sure, distill you
or
can,
six million,
there's another name called calling distillation or distill. It's a teacher-student model. So the idea is like, we don't directly learn the information or knowledge from the raw data. Instead of doing that, we learn the information and the knowledge from a model and establish the model such that I can learn faster and more effective as well as more efficient. So that's why the community thinks like DeepSeek is learning this kind of knowledge directly from the input and output from, for example, Llama and ChatGPT models.
I can also give a defense to that, right?
Sure,
I mean, like the word cheating for me is a little bit of, I don't know, look, because yes, I think the terms of service that some of these companies that produce large language models have might prohibit this explicitly, actually, right? So I don't think there is like a law, but terms of service, once you agree to use somebody's service, they might say you're not allowed to use these to train a competing model, which might be reasonable. Now, how can they enforce that? It's very hard because that would mean basically not allowing people to use their model, right? Because distilling is just copying the outputs directly from the other model. Like learning, instead of training the model on like data on the internet, you train the model on the other model outputs. Like you ask the model a question, you learn to produce the same output as the other model, right? That's distilling. But on the other hand, I mean, there is a lot of text on the internet that has already been generated and put out there, which is outputs of these models, right? So is it cheating when you ask the model directly, but it's not cheating when you crawl it out of the internet? Because people have built input, output, answers, questions, answers out of these models and put them on the text on the open internet. I think that doesn't violate the terms of service. Is that cheating though? I mean, like the large language models are reshaping how the internet looks like already. I don't know. I mean, at least it's something that like a competing company could use as an excuse.
Yeah. I also want to emphasize that knowledge distillation is a very common technique that people use to build your smaller and more efficient models based on some larger and maybe closed source models. And I think many models are already like developed or distilled from ChatGPT or Gemini, some other closed source models. And even for DeepSeek, they also open sourced some dense models distilled from DeepSeek R1 based on Llama and Q1. So I think it's just common. Yeah, I won't call it cheating.
So I'll give my perspective. So in the academic community, right, or at least like people who are working on LLMs, it is believed that if you show me an LLM with certain capability, it is very easy to achieve that. Like as Ben mentioned, teacher-students model, there exists a model with certain capability. Now, obviously that model was built with a lot of investment because you need to reach a particular capability. But once you reach a capability, distilling it down and reaching that capability is considered an easier task because you always have a supervision. Now, what is harder, it's still harder, is what is the next level of capability? This is why, OpenAI is still saying that, well, we want GPT-5. What is another level of capability and how it needs to be achieved? That requires a lot of exploration. So, I mean, again, like DeepSeek, yes, the target that DeepSeek went for was slightly easier compared to OpenAI. But I also think that they are not competing with OpenAI. They're probably competing with Meta and llamas, that is like the models that already exist there, not going to the next level of capability, which is what OpenAI's goal is.
Okay, thank you.
I would like to make one more point. Actually, instead of concerning about whether they distill the model, I think the more concerning part, including both DeepSeek and OpenAI, is where is the data from? So where is their training data from? Because neither DeepSeek nor OpenAI released the sources of their data. So this is problematic because many people doubt probably both companies use private data or data in protection in the process of training their models. However, I mean, that's just what people guess is. This is even more concern to me, yeah.
Okay. So I'd now like to see if there are any questions from the audience that the panel can address.
Thank you very much. When it comes to distillation at scale, wouldn't it be relatively easy to detect? Not by us perhaps, but by OpenAI themselves, for example, because to generate that much data through their prompts is probably something that they themselves from their website could monitor.
Yeah, I think it's possible, yeah. I mean, if there's a single set of IP addresses, I mean, it's the regular thing you use to avoid somebody overcrawling your site, right? But, there are very effective ways of going around that too. So if somebody who's very dedicated could probably try to bypass that the same way people bypass other types of similar filters, right?
I mean, I would say it's, OpenAI can maybe see whether somebody is distilling it. It's impossible to prove. I don't know. How will you prove it that this was actually a distillation and not like an honest bunch of cluster just running the model or probing the model for that matter?
I did see some possibilities if we can encode some passcodes or any watermark in the generated contents, and if we are able to reserve such watermark, we will be able to prove. But at least for now, I don't see any this kind of results. Yeah, but I mean theoretically it's possible. Yeah, but it's extremely challenging. However, yeah.
Okay, other questions?
Thank you. Got questions about the evaluation of the output of large language models, and I'll start from here. So, as I mentioned, the result function is something that we use to do sanity checks on the result of the large language models, right? But our need right now is not just the pure result, but we humans have some aesthetic needs like arts. In terms of that, because large language models is based on something that we already have. How can we possibly know that such result is a good result aesthetically? Sorry about that. And go from here. Since the prediction of the large language models is just the probability of the continuation of the prompt, then how can we enable the creativity of large language models? We may have something like, hey, we just pick some random lower probability picks to make things more random. But how can we possibly know that those lower probability picks are good in terms of improvisation? And what do y'all suggest are the path for the creativity terms of future of large language models? Thank you.
Yeah, I can answer the first question. So actually, evaluation depends on the many factors, as you already explained. It depends on the stakeholders, where you are from, and depends on the specific application. And to tackle the problem, actually, we just submitted a paper, and the paper title is The Science of Evaluating LLMs. And our first author is in the back, You can talk to him later. So the idea is like we generated, came up a pipeline of how we should evaluate large language models. So where to get the data, what are the metrics? There are like hundreds of metrics, and we categorize them in multiple subdomains that you can borrow from. So this is a very quick answer, yeah. But it highly depends on your own application and who are the stakeholders.
Yeah, yeah, I want to add a few comments. I think that's a very good question. And I would say evaluation, especially for open-ended questions, is still an open question. And it's quite challenging. And in terms of creativity, there's already a benchmark for evaluating the creativity of LM-generated text. Yeah, you may, if you are interested, you may refer to that. Yeah, and I think creativity is quite, if you want to increase the creativity of model-generated text, there are some certain techniques you can do that. Like you can increase the temperature, you can use different decoding techniques to make the generated text more diverse, but evaluation is the hardest part. Yeah.
Okay, other questions?
Thank you for your thoughts. I was wondering particularly how you were individually or for your research group deciding what model to use to accelerate your research, and maybe some tricks of how you were telling your students to approach, the absolute multitude of models that are coming out right now.
Okay, so I guess here you mean, not our research on the language models themselves, but you mean like in general, how are we using? I don't know. We're using, I think right now, if you pick the best DeepSeek or the best ChatGPT or the best cloud model, any of these, I think, for me, are more or less on the same league these days. So I think you're not going to go wrong with any of them. They're helpful for some tasks, like rearranging data in a certain way, or like writing a quick visualization thing for something you're doing. I think they come in handy for those tasks. I think I don't have a strong preference for any. In fact, right now in my class, I allow the students to use these for their assignments. I teach a very advanced class, not an introductory programming class where students actually have to learn the programming. But but in the class that I teach, I allow them to use, and I see a variety of the models that they're using and they find useful. I didn't see any particularly coming on top at the moment.
Other questions?
Howdy, in regards to the earlier conversation, in regards to safety and alignment, how, as parameters get up to, 1 trillion parameters and who knows how many, how do we, see, who's watching the watcher to make sure that the predictions, because it's not reasoning right now, it's predictions, are actually safe and they're actually, balanced and fair, and that, your health chat, bot isn't telling you to drink Drano and things like that. How are we keeping track of that and actually making sure that all these models are safe?
So, again, like we did talk about all the AI safety. My take is, look, we are in the very early phase of a technology that we don't understand, right? So it's been like 2 years, not even 2 years, like fully. Now, the way I think about it is, imagine that you have an assistant, okay, and the assistant is like mad on Tuesdays, sane on Wednesday, works sometimes on Fridays, but otherwise not. You get used to it over time, right? So this also answers the question about how do we talk about AI. Right now, we are dealing with something that we don't fully understand. Like, maybe also my mind. Sometimes I give it a problem, it doesn't come back anything. Sometimes it solves instantly, right? So we are dealing with an uncertain system. We know there are regimes where we can make it useful. We know regimes where it can create value. And there are regimes that are probably could be problematic if something goes wrong, like mission critical regimes. So I think the whole community is aware of that and they are taking it step by step seriously. The only way we'll know more is if we'll experiment more, right? That is also what that question earlier was, how can we regulate AI? I think Yes, we have to explore more carefully, but only when we know more, we'll be able to tell some of these answers. Can we regulate this? Right now, it's still like some of the open problem. Can I really guarantee that ChatGPT or somebody cannot say that don't drink something?
I will say something also here. I mean, the way people are handling it today is they're just taking a model once it's trained, they see how it behaves with these kind of questions, probing the model to do bad stuff, to say bad stuff, and then further training the model to suppress that, right? It's not very effective, it doesn't cover all use cases, but we don't have a better solution right now. That's what I will say, right, about that.
Yeah, if we circle back to software engineering, when we say like a Microsoft operating system, right? Windows system. When we see bugs, we fix the bugs. So this is what people are doing. So for AIs, probably we see problems, we fix them. So we don't have, I mean, probably it costs for the law enforcement, social scientists to set up some like guidelines, but before doing that, I mean, probably we just try and trial to see what happens.
Okay, so how about the penultimate question here?
So also on the issue of safety, but from another perspective. So Vicente, you mentioned that one of the big issues of AI safety is that people trust it too much. And I'm wondering, as sort of professors, but also AI researchers, what your perspective is on, people, CS majors passing classes without, knowing Python or something, but just because ChatGPT was able to give them some sensible code. And, on one hand, you could say it's a policy standpoint, like, government policy, but at the same time, they don't know what they're doing, in regards to tech. You guys are researchers, academics, but not in that sphere. So,
I think we have to rethink the way we do computer science, right? I think, I don't think we do it in this way at Rice anymore, but, learning new programming languages, we don't have classes that teach you new programming languages. Usually the classes are designed to teach you how to think in computational terms, right? I think that's important. And now with the coding assistance, learning a new programming language, as long as you know how to think computationally, I think this will speed up your ability to write software. Now, I think we have to rethink also the way we teach computer science from the ground up, so that we acknowledge that we live in a world where these tools do exist.
I'll just say it's beyond computer science, right? Like the entire university,
yes,
right? Or continuing education, right? Like all these things change.
Yes. I think we have to rethink education so that we integrate with these tools in a way that is productive, okay?
I will compare it with something that we have seen for understanding. So imagine calculators, right? And you're trying to teach people arithmetic. So obviously, if you're trying to teach them arithmetic, you don't allow calculators. And maybe, again, give exams that are basically take home or something because they can use calculators. But we also need to start thinking about, imagine we are going into the world where calculators are going to be freely available. So intelligence is not in the capability to do calculation fast, but the intelligence is in the capability to utilize a calculator and do something better. And I think that is what we need to go towards, is if assuming something like ChatGPT or LLMs are going to be available to everyone, it's not about whether you can reason or memorize or information because it's on your fingertips, just like your calculator. What new novel frontiers can you achieve that was impossible before that you can do now? And this is where I think the field is going. So obviously the courses will get modified, but you're right. If the course is about, I want to teach you 2 + 2 = 4, I should not allow calculator, right? That's basically.
Yeah, I would like to add
Wait, actually, I promised one more question and we're just about over time. So I will allow one more question here.
Hey, so my question's going back to distillation. So on what day did DeepSeek train Meta with distillation? Because I am running into this issue all the time. I get very inconsistent results, and especially when you're trying to apply AI in a real space, the consistency of data is very, very tricky. So did DeepSeek train it on a Monday or a Wednesday? I mean, and how does that work?
Excellent last question.
I don't know, because I cannot speak for DeepSeek. Yeah, they haven't released their data yet. So, but I do agree that like the consistency across the data is very tricky. Yeah.
So I believe what you are saying is you have hit a point where you have found a region where DeepSeek or whatever model you're using is not useful. Yeah, so maybe like, I mean, obviously in the evolution of next version, maybe it will get better. So obviously I cannot speak about what they trained it on. But if, I mean, again, right now the goal that everybody is focusing on is what regions should be focused so that we can get utility out of LLMs. And it's not surprising that.
No, it's OpenAI. It's not DeepSeek.
Okay, it's OpenAI.
An OpenAI-based application. You get different, and every time you hit enter on a certain day, you'll get different answers.
Yeah, but I mean, these are sampling from a statistical distribution, right? So every time you get a different answer, I mean, the answer should be, I mean, you're never going to get even the same phrasing for the same answer, right? Like, unless you're asking a concrete question, like, responding one word, and from this set of words, I mean, you're gonna get that kind of variability, and even there, right? So if you're relying on these for a particular application, I think typically what people do is like they specify the question a lot more so that you reduce the space of variability in the answers that you can get. I mean, that's the common solution, but yeah.
Okay, well, thank you, Vicente. And so, first off, I'd like to thank all the panelists. So thank you so much for your thoughts this evening. And then I'd like to invite everyone to join the panelists. And we got refreshments, so food and drink outside. I hope you stick around. Thank you very much for coming tonight.